In this video, we'll revise the quadratic number pattern which you have learned in grade 11. So, a quadratic number pattern's general term or formula is Tn is equals to an squared plus bn plus c. So let us look at our first example. In this example, we have a pattern of 1, 6, 15, and 28. Now, if I look at the difference between the first two terms, from 1 up until 6, that difference is 5. So I need to add 5 to 1 in order to get to 6. And then from 6 to 15, that difference is 9. And then from 15 to 28, that difference is 13. Now I can see the difference between terms is not constant. So it is not a linear number pattern. So let us consider the second differences. So from 5 to 9, we need to add 4. And from 9 to 13, we also add 4. So this second line is called the second difference. And this first line is called the first difference. And the main property of a quadratic number pattern is that the second differences are constant, meaning they are equal or the same. Now, a typical question with this type of number pattern is to determine the general term. What they mean by the general term is to find the formula for the number pattern, or the Tn equation. And we know that for a quadratic number pattern, Tn is equals to an squared plus bn plus c. Now in grade 11, you would have learned how to use these differences in order to solve the values of a, b, and c. So the second differences would be equal to 2a. The first differences would be equal to 3a plus b. And the very first term would be a plus b plus c. And we can use these properties to find the values of a, b, and c. So if I have 2a is equals to 4, I can solve for a, which is now equal to 2. Because I divide 2a by 2, and what I do on the left side, I do on the right side, and therefore a is equal to 2. Next, we have 3a plus b is equal to 5. But we already know the value of a. The value of a was equal to 2. So I substitute 2 in the place of a. So I have 3 times 2 plus b is equals to 5. So this is equal to 6, and I can transpose 6 or move it to the other side. Therefore, b would be equals to 5 minus 6. Therefore, b is equal to negative 1. So we have solved the value of a and of b. Now, a plus b plus c is equal to the first term, which is equals to 1. But we know that a is equals to 2, b is equals to negative 1, and we can now solve c. So again, I simply substitute a with 2 and b with negative 1 in order to eliminate the variables, and that allows me to solve c. So 2 minus 1 is plus 1, and I move the plus 1 over to the other side, so it'll be 1 minus 1. Therefore, c is equal to 0. So if I want to answer the question of what is the general term, I have Tn is equals to an squared plus bn plus c. But we know that a is equals to 2, so it's 2n squared, plus b, which is negative 1n, plus c, which is 0. Now, we can drop the 0, so the term, or the general term for this equation would be 2n squared minus 1. Now, another question they can ask, following up from the first one, would be, find the value of the 20th term. So we have established that the general term, or the general rule for this pattern is 2n squared minus 1. And if I want to find the 20th term, I replace all the n values with 20. Notice that I'm using brackets when I substitute n with 20. The brackets are there to remind me that I'm squaring the 20 and not 40. So I'm not squaring 2 times 20, which is 40 squared. I only need to square the 20. It's also helpful when you use your calculator to use brackets, as this will help you avoid these common mistakes. So when I substitute those in, I have the 20th term is equals to 780. And the final type of question that I can ask on a quadratic number pattern is, which term would be equal to 3160? This is not the same as saying, find the value of term 3160. What they are asking us is, in the pattern of 1, 6, 15, and 28, and if I continue that pattern, which value or which term would be equal to 3160? So that means the Tn value is 3160. And I want to solve the value of n for where this value would be true. So notice that I substitute Tn with 3160, and I'm now going to solve the values of n. And I identify this as a quadratic equation. So with a quadratic equation, I want to take everything to one side and make it all equal to 0. So I'll move the 3160 to the right-hand side. Now the equation is equal to 0. And if you are comfortable, you can factorize this equation. And if you're not so comfortable, you can always use the quadratic formula to help you solve n. And remember, for the quadratic formula, you would use, instead of x, you would use n is equal to minus b plus minus b squared minus 4ac, to take the square root of that, over 2a. So your b value would be equals to -1, your a value would be equals to 2, and your c value is equal to 0. Remember, we dropped the 0 in our previous example. So that will give you two values of n. So n is equals to 40, or n is equals to -79 over 2. But because this is a number pattern of 1, 6, 15, 28, and so forth, the first term is term 1, the second term is term 2. So these values of n must always be positive whole numbers or natural numbers. So the only valid solution would be n is equals to 40. So you can't get a number pattern or a term that is a negative value, because our terms start at term 1. So therefore n cannot be equals to -79 over 2. Therefore the 40th term is equal to, so term 40 is equals to 3160. And that is the basics of a quadratic number pattern.